Hey guys, we're finishing up the year now. We're going to be learning how to solve a system of linear quadratic functions, and we're going to work on one method today and another method tomorrow. So make sure you have this out, the packet out, and follow along and take the notes and pause the video when necessary to get all the proper notes down. So the first thing is, don't forget, a system is when you have two or more equations given at the same time in the same problem. A linear function or a linear equation in the form of y equals mx plus b forms a line, and a quadratic equation in y equals ax squared plus bx plus c forms a parabola. So what we're going to be doing today is solving solving a system with these two types of graphs. Okay, pause the video, make sure you get it down. So how can we solve them? The first method we did back in the day was graphically. So that just means we're going to be putting it on a piece of graph paper. And then we go into algebraically, which is what we're going to be doing algebraically. Got to know how to spell. All right. So those are going to be the two methods that we're going to finish the year off with. Pause the video, make sure you get this down. So here are possible solutions. Don't forget, when you're solving a system, you're looking for your points of intersection, which is our POI. We always have to write those down for a solution to a system. Now, with a quadratic linear function or a system, we can actually have two solutions because it can cross twice. Those points of intersection are solutions. So there are two solutions. Here, if the line is tangent to the quadratic, there's only one point of intersection. So therefore, there's only one solution. And if there are no points of intersection, there are no solutions. Okay, pause the video, make sure you get this down. So don't forget, when you're finding your solutions, you have to name those coordinates. So this system has two solutions, and those solutions are 0, 2, and 4, -5, because those are the coordinates of the points of intersection. Pause the video, make sure you get that down. Where in this one, there's only one coordinate or one point of intersection, which is 4, -5. Therefore, this only has one solution. Remember, that's where they're equal. The two graphs are equal is where they cross each other at the same point. Pause the video, make sure you get that down. And then your last one is no points of intersection. So if there's no points of intersection, there is no solution. There's nothing equal about those two graphs. Okay, pause the video, make sure you get that down. All right, so here we go. We're going to do one together. The reason why we're only doing one together, because this is all a big review. So we're kind of like moshing two equations into one, or two lessons into one. So one old lesson, one new lesson. We know how to graph quadratics. Now we just have to remind ourselves how to graph a line. So in order to plug anything into our calculator, we need to make sure y is by itself. So in the first quadratic, it's in good form. If not, you would have to get y by itself. In the second one, I purposely didn't make it y by itself because I want to review this in case you see one of these on Delta Math, okay? So don't forget, your first step is to move the x term over, and we're left with -2y equals 4 minus 4x. You cannot subtract those. They're not like terms. The next thing is divide by -2 to get rid of that -2 in front of y. Remember, get rid of everything in front of y. So it's positive. 4 divided by -2 is -2. -4, don't forget that's a -4, divided by -2 is +2. Bring that x down. Now it's in perfect form. So what I'm going to do is I'm going to plug this into y1, and I'm going to plug this into y2, and I'm going to look for my points of intersection. That's a really important skill. So I already have the quadratic in there. I'm going to plug in the other one, which is -2 plus 2x. So you're going to graph it. And if you notice, the blue graph is your parabola, the red is you have 2 points of intersection. So let's just use this, because sometimes your points of intersection will not be found in the table because they are not perfect points. So you need to know how to use this other calc button. So you're going to press second and trace to get to calc, and we're going to go to intersect. So go down to 5, press enter. And what you're going to do is you're going to move that cursor over that point of intersection and press enter 3 times. And it gives you your answer. So what you want to do, your goal is to have those points of intersection written down So if you do that right away, you'll have your answer right there, but then you just have to show your work after. So it's important to get those down so you don't have to worry about writing it later. So I'm going to calculate my second point of intersection, second calc, intersect, go down to 5, press enter. Now moving up. Oop, I want to get on the line shorter. So I'm going to keep going over, so I get close to that point of intersection. Press enter 1, 2, 3 times. And my other point of intersection is 4, 6. Okay. So now that I know my points of intersection, I'm going to graph my parabola. So I'm going to get it on the paper. So I'm going to need, this is going to be a 3-column table. I'm going to go to my table. I'm going to copy down a good set of points. I would love my points of intersection to be there. So I'm going to make sure that -1, 4 is in my table. Actually, maybe I'll start with -2 because I can graph all those points. So we're going to start our table at -2 because it will safely encompass both my points of intersection, and it will also give me a good range for the graph. So I'm going to start -2, -1, 0, 1, 2, 3, 4, 5. I'm going to go up to 5 because 4 is my last point of intersection. I'm just going to draw some lines to make it neater. We're going to copy down all the points for y that are associated with those points. And my first one is 0 and -6. -4 and -4. Like we said, that's our point of intersection. Got it. -6, -2. -6, 0. -4, 2. 0, 4. 6, 6, check, got that point. And then 5 would be 14, 8. So I'm probably not going to be graphing that one because the 14's off the graph paper, but that's okay. All right. Now, if you notice, my parabola doesn't have my vertex there. So I know my vertex is going to be at 0.5 because it's in between 0 and 1. So make sure you get it. You don't have a flat. Just put a point a little bit lower than -6 so you have a nice curvature to your parabola. So I'm going to do the parabola in blue and then the line in red. So I'm first going to go -2, 0, which is here. -1, -4. 0, -6. 1, -6. So I'm going to put a little dot in between there, a little lower. I know mine's not calibrated, so it's not going to be perfect, but just make sure you get that curvature to that one. And then we have 4, 6. So I'm going to be going over to 4, up 1, 2, 4, 6. I'm going to actually get the other side for my points of symmetry, okay? Erase that. That's a weirdo point in there. Sorry about that. All right, so I'm going to graph it, make sure I curve it, and it's not a flat parabola. Now, again, if it's on a piece of paper, yours should be a little neater. Mine is disgusting. I apologize. So we have y equals, label it, x squared minus x minus 6. Okay, so there's my parabola. Now I'm going to graph my line in red. So I'm going to use these points for the line, for the y. So I have -2, -6. -1, -4, which is that point of intersection. 0, -2, 1, 0, 2, 2, 3, 4, 4, 6, my other point of intersection, and then 5, 8. Now, if you didn't graph that last 5, 8, it's just really important that you use your ruler to extend through so you can safely see those points of intersection. Label the line 4x minus 2y equals 4. Okay, and I have my points of intersection labeled. I have my work for my graph. I have my graphs labeled. If you want, you could circle those points of intersection, but you just need to make sure that they're labeled. And that's it. Okay, so pause the video, make sure you get all of this down. And just go back to the Google Classroom, complete the Delta Math assignment on solving systems of quadratic linear functions graphically. There's going to be one graph, and then there's going to be about 5 just finding the points, okay? So message me if you have any questions, and good luck.